Distinguished delegates, welcome back to the International Conference on Networks, Computing Systems, and Data Analytics, ICNCDA 2026, organized by the University of Essex, Colchester, England, United Kingdom. The technical paper presentations have been both intellectually engaging and academically rewarding. Throughout the parallel sessions, we witnessed a diverse range of high quality research, contributions spanning networks and communication technologies, computing systems, artificial intelligence, cybersecurity, data analytics, emerging technologies, and responsible AI. The organizing committee extends its appreciation to all the presenting authors for sharing their research, to the session chairs for moderating the technical discussions with professionalism and academic rigor, and to every participant whose engagement contributed to the success of today's program. We shall now continue with the keynote sessions scheduled for this conference. It is now my privilege to introduce our distinguished keynote speaker, Professor Hoang Na Nguyen, Associate Professor in Cybersecurity and Formal Methods at Swansea University, United Kingdom. Professor Nguyen is a distinguished researcher whose work focuses on cybersecurity, formal verification, dependable software systems, and secure computing methodologies. Her research has made significant contributions towards strengthening the reliability, security, and resilience of modern computing systems. Her expertise in cybersecurity and formal methods align closely with the objectives of ICNCDA 2026, where the advancements of secure, intelligent, and trustworthy computing technologies remains a central focus. It is our honor to invite Professor Hoang Na Nguyen to deliver her keynote address. Professor, we warmly welcome you here.
Thank you very much. I just want to work on the technical things. So I just want to check if everyone can see my share screen.
Yes, it's visible.
Yes. Okay. So shall I start?
Sure, go ahead.
Yeah. So thank you. I think I understand that I have 15 minutes. So let's crack on. Uh, Good afternoon, everyone, and thank you very much for inviting me to give the keynote presentation at the conference, and also for very kind introductions. I would wish to all of you a very successful and productive conference. Um, in my keynote today, I will present, very quickly about our recent work in the area of automated threat modeling for aerospace domain. The work was carried out in collaboration with Nova Engineering and was funded by Airbus Endeavour. So it was only for very short time earlier this year. Um, okay. So the outline of the talk is as follows. I would cover some of the context of the problem in the introduction. Then I would briefly present about the inherent challenges and the goals uh, that we aim to achieve, right? And then I would talk about the approach that we propose, which is based on ontology and a small example to show how it works very briefly. And finally, we will have a very short summaries and some of the direction for the future. Firstly, it is actually very common things now we heard about in many other domains, but I think especially in the domain of aerospace and security is very important, and it need to be addressed as early as possible to ensure the quality of the product, which includes system and subsystem airplane, which is quite an obvious thing. And the usual thing that we can think about is that the earlier security is considered the more advantaged manufacturers could benefit such as to have secure product and also to reduce both the design and the cost of manufacturing. It is not surprised that in the aerospace domain, this has been standardized. We have standards in place such as the DO 326 and 356. Um, that require the compliance from aerospace manufacturers and suppliers. This type of standard requires a security consideration much early from the conceptual stage. Um, in the figure that you can see on the right hand side here, this is the actual process that is required by the standards. So basically, you have some input from the design, such as the design system, some analysis from the safety analysis, such as the failure condition and the level of severity, and also some of the security aspects, such as the environment and the boundaries. And then there are four basic activities that need to be done, required to be done by the standard. First is to identify the threat condition, which is about talking about the impact of certain security violation that lead to failure conditions associated with the corresponding severity come from the safety analysis. And then also the threats identification here, talking about how that kind of security violation can be carried out, starting from some attack vector through some way through system. From the design phase, we mostly talking about data flow, and then that will directly create the impact based on the failure condition severity. And then also in the design, there may be some security measure. We need to describe the security measure, analyze it, and see the effectiveness it has on certain kind of threats, and then identify the level of protection, and then identify the level of threat, which is talking about the feasibility of the threat, which also another word to say, what is the likelihood the threat can happen. And based on that, we have the threat levels, which is talking about likelihood. We have the impact from the failure condition. Then we can identify the level of risk according to the standard. So they predefine a set of different risk levels there. Um, so in practice, how organizations can comply with such standard is can be very, so they are free to define their own process to adhere to the required process from the standard. From our observation and our contact with some manufacturers, then the main current approach is talking about is so it's ad hoc and manual manner. They heavily depend on the knowledge of the expert about existing vulnerabilities, about known attacks, about available security measures. The consequence of this means that the process usually going to be very highly manual, very time consuming, and particularly it is very inconsistent in the meaning that if this process is carried out by different people, different security experts, we can have different results, and sometimes the results can conflict with each other. Um, so so the goal here, obviously, for the work, then we have a very short time, so we just look at whether there is any way to have the security expert to uh, to streamline the whole process, and eventually to do it in a systematic way. So our aim is here is to develop and demonstrate an approach that can both comprehensive and systematic to ensure the security risk assessment process can be carried out thoroughly, consistently by using ontology modeling that can help to make it easier for the identification of threat, risks, condition. In this activity, then we have to talking about how do we model a system in ontology and how we can use that model to help the modeling of the threat here, and also to evaluate the threat. Okay, so I quickly go into the ontology approach. So the approach is centralized on the ontology, obviously. So we have an ontology model, which is carry out the meta model of the whole system. So the main idea here is that we use the ontology in the center, holding information about system, we holding information about known attack, and combined with the security knowledge such as from literatures and from security expert that can encode it into some rules, and we can using that all kind of information to infer automatically uh, all the information that required by the security risk assessment process. So let me talk first about the ontology very quickly. So we divided ontology into four subcategories. One is talking about system design. One is talking about threats. Another one talking about safety and failure condition. And finally, another one is talking about security measure. So first, when we talk about um, system design, so this one actually built on some of the existing work. So let's quickly go through them. So system design can be captured by using concepts such as the asset that system can have, the data flow that can flow through the assets. The asset can also be subcategorized into further classes, subclasses such as device for hardware component service, for software component network, for the communication links between different assets, and also network devices, like such as for router for network devices, gateway for network devices. Right? I would not talk much about the other, but they hopefully they would make sense. But the main important one is obviously asset, and we talk next is about the threats. So for the attacks, for the known attack, then we directly use the concept of attack patterns that from the open database of attack patterns called Carpet. The attack pattern, according to the database, attacking the database is subcategorized into different classes of the attack, depending based on the nature. For example, the attack would directly mainly targeting communication link, mainly targeting devices, targeting software, and so on. Uh, then the next one is a failure condition where we're talking about to try to capture the safety analysis here. So every failure condition would, depending on other conditions such as the weather, the fly phase, and also what kind of security property, when it's violated, can cause the failure condition, and also the level of impact that the failure condition has. And finally, when the asset will be when the attack violate the property affecting asset that could lead to the failure condition, so we capture all of those in this sub ontology. And then finally, the security measure is captured in different, but captured by, obviously, I know there is a typo here, so I apologize for that. But it tried to capture the different aspect of the attack that it prevent from. So it's talking about how effective it is, what kind of step of the attack that can prevent from, what kind of window opportunity the attack would try to target, whether it would have to increase the requirement of the equipment and also increase the requirement of knowledge of the attacker. Um, of course, we also associate every security measure with certain asset here, so that's a link between them. And this, you can see that this is part of the first subcategory that I introduced first when we're talking about system design. Let's talk about an example here. So on the top right, you have an example of a very typical flight management system in airplane. So flight management system is very, very crucial. It provides information and support certain function for the pilot. Uh, for the for the redundancy purpose, and the flight management system would be include two units in there. So if one unit fails, then the other is still up and running. So it would improve the the reliability of the whole system. Then it connected to some of the router to the tablet, onboard tablet, the router, another communication router that connected to the ground infrastructure through the VHF data link. Of course, on the other side, it also connected to other subsystem in the airplane. So the table around this, you can see it's the diagram. It just shows how we transform the model of the system into the ontology. For example, some of the hardware component would become devices. Some of the router network devices become gateway in let's say that instance of the gateway classes. Some of the external service, software service, such as the onboard tablet and also the route infrastructure. The communication link, for example, between the router and the flight management unit would become an instance of the network, and so on and so on. We're also talking about the transformation from the failure condition from the safety analysis here. We're talking about, for example, one failure condition could be the loss of flight management capability. And depending on the condition, for example, if this is under bad weather, and in flight, um, that could have a different failure category. So it can be when it's we can imagine when the weather is not good, then it could be more severe than when the weather is less is better, or when the airplane is in fly mode, it would be a lot better than when it's on the ground. So it would be more worse on when it's on the ground. So obviously, it doesn't mean that depending on the condition, impact and the failure condition can be run differently. Um, and then another transformation that we need to be done is about non-attack pattern. For example, here we have the direct transformation from the CAPEX. Uh, the example you see here is the attack pattern talking about interception of the network. So attacker can intercept the network and monitor the network and sniffing the data from the network. So from this one, we look at this is the direct screenshot from the attack pattern on the CAPEX database. And um, look at the domain, for example, it's talking about communication. So we can talk about, okay, this attack can be categorized as an attack on the communication and also on service as well. And then look at the scope, information about the scope here. Then it's also talking about the attack would try to violate confidentiality, and which means that the attack can be classified as information disclosure according to the strike classification. Okay, so I do know that I run quite fast, but um, I hope that it's clear enough so far. And then we have all those things. How do we infer threat? So an example, an obvious way to do is to use rules in ontology. So we can use a number of rules. So particularly this one, we're taking it from the literatures. Um, this one is a very simple rule, but it's from the literature, but it illustrates how it can work. So we just say that if I have a network component and I have an attack that is targeting the communication, then we can conclude that the network can be attacked by this attack. So an example here is that you can see that we have a network, for example, like the network that connected the router to the FMU2, and the attack pattern CAPEX here that is classified as communication attack pattern. Combine these two together, we can conclude that this network is affected by this attack pattern, and that allow us to generate a list of threats fairly quickly. In this example, very simple example, then we can consistently generate the list of about 40 threat conditions. So we're talking about what asset is affected here by what kind of threats, and then what is the impact in the end. So you can see that under the bad weather, the impact going to be higher than under the good weather. So it's going to be minor here. Or when it's in the fly, when it's on the ground, then it's going to be less severe than when it's it's flying on the air, right? And then we further on, we can using the same kind of query on ontology, we can infer about the threat scenario. We're talking about where the attack vector come from, where, follow which data flow, which is about talking about attack path and targeting which target. And then along the way, um, there would be this security measure along the way, and it's going to be specify how effective it is, and that be, could combine to say that we have. So we say that with this, it can reduce the um, um, so this. Sorry, I need to close the door. Um, severity. So the likelihood of the attack, and then you can talk about severity, and combine these two together. We can talk about whether the risk, what can be the risk going to be. For example, if the level of threat is very high, this comes from the level of protection. And the severity is minor, then the risk level is going to be talking about acceptable. But when you have a very high severity level and the level of threat is also high, then the risk evaluation would be not acceptable. So when it means that, then we have to return the report here to say back to the designer, say that we need to improve some of the security measure to reduce to make it the risk become acceptable in that case. So in this one, then we can see also talking about attack path, what kind of attack here, what is the failure condition, severity and condition, and what is the level of threat. By combining this together, we can infer the threat scenario for every the risk level of every threat scenario. I think that is for the approach. So in conclusion, I would say that I briefly introduce the approach here about threat modeling using ontology for the aerospace domain, which help to conduct risk assessment in a systematic and consistent way. And for the future, we wish to further approach with extended expert knowledge encoded into the ontology, with some automated pipeline for it and improve certain aspects with AI approaches. And thank you very much and wish the conference all a great success. Thank you.
Thank you so much, Professor, for your insightful and thought provoking keynote address. We sincerely appreciate your valuable contribution and thank you for sharing your expertise and research perspectives with the global academic community gathered today. Kindly note that there will not be a live question and answer session following the keynote. Participants wishing to communicate with the speaker may kindly forward their queries through the organizing committee at support@icncda.co.uk or icncda.congress@gmail.com. I repeat, participants wishing to communicate with the speaker may kindly forward their queries through the organizing committee at support@icncda.co.uk or icncda.congress@gmail.com. We shall now proceed to our next keynote address. It is my privilege to introduce Professor Sanjay Kumar Panda, Assistant Professor in the Department of Computer Science and Engineering at the National Institute of Technology, Warangal, India. Professor's research encompasses artificial intelligence, machine learning, intelligent computing, and data-driven technologies, with significant contributions to both academic research and engineering education. His work continues to advance the development of intelligent computational systems capable of addressing complex real-world challenges. It is our distinct pleasure to invite Professor Sanjay Kumar Panda to deliver his keynote address. Professor, the floor is yours.
Yeah, thank you very much, Ms. Tanvi, for introducing me. I hope my slide is visible.
Yes, sir.
Yeah,
It is
thank you
visible.
very much. So I would like to thank the organizer of this conference for giving me an opportunity to speak in this yeah, wonderful international conference. The topic that I am going to discuss is quite a new topic. It is called as osmotic computing, which is I can say 8 9 years old, and it is an emerging computing paradigm between the cloud and edge computing, and as well as it is an emerging computing paradigm between edge and IoT. The content of this keynote is that I'm going to briefly discuss about the different layers of paradigms. You know that computing paradigm is not new. We have parallel distributed computing, we have distributed computing, we have edge computing, we have cluster computing, we have grid computing. Like that, the latest invention in the computing is called as osmotic computing. And also, I'll highlight about how a osmotic computing system look like and how we migrate based upon the requirement to different layers of the computing paradigms and what are the applications of these new computing paradigms followed by the research trends. So coming to osmotic computing, it is not a new computing, rather than it is the integration of various paradigms like Internet of Things, edge computing, fog computing, and cloud computing. As you know that there are many IoT devices or sensors or actuators or different handheld devices we are using in our life, but these are very tiny devices to do the computation. That's why they depend upon other layers to perform the computations. For example, they can migrate to the edge layer. If their computation is fulfilled, then they will get back the result. If the result is it cannot be processed in the edge layer, then they will migrate to fog layer. Similarly, if fog layer is incapable, it can go to the cloud layer. So the main purpose of going for the osmotic computing is to deal with various latency sensitive data, like basically when we go for healthcare, when we go for monitoring unit. So you know that there are many tasks that are generated which need to be immediately solved. In such cases, osmotic computing to wander. So it basically focuses on how to deploy, how to migrate, how to optimize various applications in the form of migration. You can see the variety of applications starting from intelligent transportation system, smart city, education, smart healthcare, industry 4.0, even if industry 5.0, all these cases osmotic computing is widely used. You know that there is a difficulty in the IoT data, like we wear smart watches, we have smart devices, smart phones, and various handheld devices is having dozens of sensors, but they cannot keep the data for longer time. So they depend in the cloud to push the data to the different data centers or the cloud. But the data center in cloud is not near to the user. So as a result, they suffer from the latency issues, bandwidth issues. In fact, they are having issues with our backbone networks. So in order to deal with that, there are different layers that are introduced in between the IoT cloud, and these layers are called as edge layer, as well as the fog layer. Basically, we can provide the quality of experience to the user in by introducing these two layers. And fog is very close to the handheld devices or the user, so they can compute, they can store, they can process any information as quick as possible compared to the cloud. So it is well suitable when your application is time critical, or it is time sensitive application, or it is a low latency applications. So some of the devices, well-known devices, it is a smartphone, or we have a switches or routers, these can be considered as different fog devices. Coming to the edge computing, and this picture shows a clear difference between these four layers. You can see the very bottom layer is called as IoT sensor. They are connected to the edge layer. Then edge layers are further connected to fog layer. Fog layers are the cloud. Earlier, the IoT data, whatever it is collected, is pushed to the cloud layer. So irrespective of the type of data, irrespective of the variety of the data, all are stored in the cloud. So processing such data in the cloud is creating a lot of challenge. So by introducing this edge and fog layer, the burden on the cloud is going to be reduced. But these two layers are not replacement of the cloud layer. In fact, they don't have that much capable the cloud layer. That's why they are just like a complement layer, right? And you can get a decision for edge in the edge layer or the fog layer. But computation wise, cloud is the one of the paradigm which is massive computation power, massive storage. But based on the requirement, you can see whether our work can be solved in the edge layer, fog layer, or the cloud layer. So this picture shows that the integration of two different technologies like Internet of Things and Edge, it also shows the integration of Edge to the cloud. So where actually the osmotic computing come into the. So the main goal of this osmotic computing is to balance the load between the IoT layer and Edge layer. It also balances the load between the Edge layer and the cloud layer. The, the main goal of behind balancing the load is to also to utilize the resources that are available in different layers. So basically it focuses on systematic allocation of the resources to different tasks by following a concept of osmosis, which was widely studied in the field of chemistry. So as IoT applications require latency sensitive solutions, low energy usage, and most of the application nowadays focuses on sustainability, minimizing the energy consumption. So Osmotic can do it by introducing different micro data center near to the user. And it uses different microservices, and microservices are lightweight. Even if a service is going to be failed due to some circumstance, it is not going to impact other services. And it is fine grained, it is independently deployable, and it is increasing the cohesion and decreasing the coupling. So microservices is a better services compared to the traditional service oriented architecture, or it is also supplement to the earlier architecture where it is a dumb terminal which is responsible for all types of services. Coming to the components of the osmotic ecosystem, is okay, osmotic ecosystem is having 5 different components. They are solute, solvent, solution, and there is a semi-permeable membrane and concentration. It is as simple as I am taking a glass of water and I am putting, let's say, a spoon of salt inside that water. So you know that if the concentration is well, then it is going to be dissolved. But if the concentration is not good, it is not going to be dissolved. Based upon that concept, people have come up with the concept of osmotic computing. Like you can see here, we have a cloud layer. On the other hand, we have a edge layer. Sometimes edge layers are overloaded, and sometimes cloud is also overloaded. So they can share their load based upon their requirement. Like here you can see, there are different solvent particles are there, solute is there. So when there is a more solvent is present in one side, that is called as high solvent concentration. Normally we move from high solvent concentration to a low solvent concentration, or we move from the low solute concentration to the high solute concentration. And who is going to decide that? For that, you can see there is a dotted line in between that, which represents the semi-permeable membrane. And in the field of software development also, people have integrated the semi-permeable membrane. So we call that as a software development. So the basic idea of taking these two part of two different computing paradigm is to balance the load among themselves and utilize their resources properly. So in technical content, we can say that solute is nothing but how much time it is taken to process a particular request, what is the power requirement, what is the energy requirement. On the other hand, solvent primarily focuses on different kind of application. It also focuses on services as well as the microservices. And the semi-permeable membrane is taken care of how to make a balance between solute as well as the solvent. Based upon that, there is a well-known area has started now, which is based upon energy efficient, which primarily focus on how to minimize the energy, how to minimize the number of migration, and so on. There are various aspects you can look for osmotic. The first aspect is that you know that it is a distributed environment. It is also a federated environment. If it is a unified environment, or if it is only a single environment, deployment of microservice becomes easier. But when we think about distributed environment, so dealing with microservices is quite challenging. Similarly, as we migrate from IoT layer to edge layer or edge layer to cloud layer, we have to see that our services are continuing. So we need to see that how the resources are seamlessly co-located from one computing paradigm to other. You can think about hot migration. You can look at the cold migration. So migration is also one of the aspects that are working in the. Another aspect you can look that how to utilize the resources, how to make the more resources available so that the unpredicted demands can be handled is also one of the area. Similarly, controlling and managing service heterogeneity, because the services that are provided by these layers are with different servers or different micro data centers. And these data centers are not these data centers are not homogeneous. They are heterogeneous, they are different, their capability is different, way of processing is different, networking is different. So in that environment, how we are going to serve different kind of tasks, so that's also quite. And as I mentioned that people primarily focus on this particular computing paradigm because of low latency as well as minimizing the energy consumption. So here you can see that this microservices or osmotic computing is depends on a micro element. Like as you can see in the concentration of cloud and edge, you can see there are four number of triangles which represent the edge micro element, and the circle represent the cloud micro element. So there is a migration from edge micro element to cloud micro element because the load on the server is quite high compared to the cloud. In another scenario, you can see here the load on the cloud is quite high, but edge data centers are free. In that particular case, the a cloud micro element can also be migrated to the, but there is no paradigm till now before the osmotic computing which deal with the bidirectional flow between two different. So that is completely new in the osmotic computing paradigm. And isolation of one layer with another layer through the semi-permeable membrane ensure that there is no issues. Issues. It also ensures that there is no intrusion in the complex system. So we need to decide that which load we need to estimate the load. Based upon that, we can decide whether to migrate from edge to cloud or cloud to edge. On the other hand, we need to decide whether to migrate from the edge to IoT edge. So here you can see there are different type of IoT devices, and there is a osmotic layer in IoT to the edge, and there is a osmotic layer between the edge to cloud. In order to take a decision that whether a task which is generated by these IoT devices, whether it will be executed in the IoT layer or it will be executed in the edge layer, so there is a osmotic task manager that are placed in the semi-permeable membrane. So when a request is reached to osmotic task manager, it takes a decision that whether the task can be executed in the IoT layer itself or there is a requirement to move it to the edge layer. If it accepts for the edge layer, you can see in edge layer there are different micro data centers are there. Based on the proximity of that particular user request, it will be allocated to one of the edge micro data center. But there may be also a case when the edge computing paradigm or these edge micro data centers are incapable to do that. In that case, there is also another osmotic task manager between the edge layer and cloud layer to handle that particular request, to take a decision that a new edge micro data center can solve that one, or we need to migrate it to the cloud data center. And many times, osmotic task managers are also responsible for various computational operators like filtering approach, aggregation operator, mixed minimum value, maximum value, average value. All these things are also manager. There is another typical scenario which you can see here, that there are different type of microservices. One microservice may be a general purpose microservice. Another microservice is primarily focused for the network management. Another microservice may be primarily focused on the security management. So when you go for a two layer, whether it is in between IoT to the edge or it will the edge to cloud, so this two layer federated cloud environment need to decide that which one will be the appropriate one if a particular task is not solved in the edge data center. For example, you can see that this particular edge data center is having three type of micro. However, this particular edge data center is having only two types. You need to decide that when there is a scarcity of resources in a particular data center, to whom you are going to be connected. Like all the cloud data center may not have that microservices also. For example, if there is a requirement of microservice in security, related to security, it need to connect to the cloud data center which provide that security services. So there are various factors people have assumed that whether the quality of service is satisfied or not, because quality of service will not satisfy if I go for cloud data center B to solve a problem which requirement is microservices for security management. That's why that management need can care. So there are various type of challenges in this particular environment, like latency is a challenge, throughput is a challenge, security is a challenge, budget is also one of the challenge. So based upon that, people have developed a different signaling problems, different security privacy issues, different load balancing issues in this particular osmotic environment. And these are some of the articles, categorization of articles in different area. So you can see that people have also integrated osmotic computing, healthcare, osmotic computing is many monitoring environment, be a structural monitoring, or it is a monitoring of a building, or monitoring of a let's say a bridge, or monitoring with any particular environment. Also, people have integrated with the blockchain. They integrated with IoT and industrial IoT. They also integrated with smart city application, and they also worked in the orchestration and networking. So these are the different areas which you the osmotic computing. To conclude my keynote, I can say although we are having different computing paradigms to integrate in the osmotic computing environment, in fact, it is quite challenging for integration of this environment. Like developing a particular tool which can deal with this environment is also quite challenging. And in practical scenario, you can see different tiers are taken care by different providers. So the relationship between these providers also required, or the agreements between these providers are required for increasing the business opportunity. The main challenging issue is that if you can develop a particular data set that can be helpful for this particular environment, and in fact there is no real-time data sets are available for this particular research area. These are the things which you can take care for doing further research in the field of cosmetics. So these are the some of the references, and the very first reference is the very best paper of computing, and the second last paper is the first systematic review paper, which is published in the Asian Transaction on IoT by my research. Yeah, thank you everyone.
Thank you so much, Professor, for your enlightening presentation and for sharing your valuable research insights with us. Your address has provided meaningful perspectives on emerging developments in intelligent computing and artificial intelligence. We sincerely appreciate your gracious presence at ICNCDA 2026. We now proceed to the final keynote session of today's conference. It is my privilege to introduce Professor Shivani Bali, professor at the Jindal School of Banking and Finance, OP Jindal Global University, India. Professor Bali is an accomplished academic whose work spans financial technologies, digital transformation, artificial intelligence, and data driven decision making. Her interdisciplinary research bridges technology in analytics and finance, offering valuable perspectives on the application of intelligent systems across contemporary business and financial ecosystems. It is our honor to invite Professor Shivani Bali to deliver the concluding keynote address of ICNCDA 2026. Professor, we warmly welcome you here.
Thank you. Thank you so much for such a warm welcome and giving my introduction. So first of all, I would like to, express my thank to the conference organizer for inviting me to this international conference. So, my topic would be related to circular economy in Triple E sector. So you just give me a time to share my slide. I hope the presentation is visible.
Yes, ma'am, good to go.
Okay, thank you. So, this is the topic of my presentation. So basically, I would be, discussing here with you the two research papers which I've already dealt with. These two research papers. So second one is an outcome of the first research paper. So first of all, the introduction about the topic and the motivation why, I've done this research. So we all know, so since many youngsters are here, so electronic products are being, the sales of electronic products have increased, drastically. Why? Because of the convincing marketing strategies and, designing of new products. Earlier, the life of mobile phone is 2 years, but now it has been reduced to 1 year. So after every 1 year, most of the consumers, they want to change their mobile phones. And same is with, the other electronic devices, laptops, and, the household electronic products. Not exactly 1 year, but yes, the changing period has been, changed. So this has led to an exponential rise of triple E waste. And if we see, India ranks third in electronic waste production in the world after China and USA. And the data from markets and data, it says that in year 2022, India generated approximately 1.6 million tons of e-waste, and it is projected to reach 29 million tons by 2030. Hence, this raises a critical sustainability and supply chain concerns, indicates a pressing need to implement circular economy strategies and involve all stakeholders in the electronic value chain. So that was the motivation behind doing this research. So we have identified two problem statements. So one problem statement is to understand the CE transition at a firm level in Indian triple E sector. And the second is to determine the vital enablers and levers of CE transition in the Indian triple E sector. So before we find out the enablers and levers, so we have to first actually, explore how the transition or the adoption of circular economy is taking place in the industrial setup, and we are restricted to electronic industry only. The research objectives are to understand the firm level C transition in triple E sector. The second objective is to identify and analyze the critical enablers and levers of C transition in the triple E sector. And the third objective is to develop a comprehensive framework for ranking and measuring the interrelationship amongst these enablers and levers, And then we have our fourth objective to highlight managerial, societal, and policy implications of sea transition at a firm level, contributing to the achievement of sustainable and resilient supply chains of future. So these are the 8 research questions that we have answered through our research work. So first 4 research questions are basically from the literature review that we had done, and the remaining 4 questions, question number 5 to 8. So this is one of the gaps that we have identified through our systematic literature review. Then we have the scope of the study. So, as I've already discussed, the scope of the study is EEE sector with a special focus on Indian context. So, the primary focus is on India because of the increase in the manufacturing of electronic products, escalating e-waste challenges, and evolving regulatory landscape. First of all, we'll talk about literature review, wherein we have answered the first 4 research questions. So we have performed a systematic literature review. So in that, the keywords were all related to circular economy and the electronic sector, electronic industry, all those terms we have been taken. The database is the Scoopers database, because we could get the major publishers like Emerald, IEEE, Springer, elsewhere, so on and so forth. The inclusion criteria that we have taken during our systematic process is that we included articles only in the English language, and then the domain is the business and management area. We did have an exclusion criteria, which is like we did not take papers, the conference papers or book chapters, etc. So they were only the journal papers. After having those papers, so we had a second stage review wherein we have reviewed all the papers, we have shortlisted them and identified into different themes, and finally we came up with the research gaps, future research directions, right, the conclusion and the managerial implication. So when we did our systematic literature review, so the final papers that we boiled down to, they were 94 papers, and the year that we have taken for the analysis of these research papers was from 2010 to 2024. And you could see from the figure. So 2010, there was only one paper, 13, there was only one paper. And after that, we have seen a significant increase in the papers because of the adoption interest in of the circular economy. So what we did was, since we had 94 papers, now we have to extract themes out of those papers. So how can we categorize, how can we put these 94 papers into different categories? So after analyzing all the papers, so we are the team of researchers. So what we could identify is that mostly these papers falls into these 3 themes, which is an ecosystem, design strategies, and circular economy business models. So 42 papers were put into the category of ecosystem, which can be defined as a complete network of entities like people, tools, organization, interconnected through strategic relationships and exhibiting co-evolutionary behavior. Then we had design strategies, which refers to strategic decisions that businesses must make when implementing a circular economy. Then, of course, we have circular economy business models, or the approaches that integrate sustainability by reducing waste and enhancing resource efficiency. So once we did that, then further we analyzed those papers. So under ecosystem, these papers was further segregated into sub-themes, which were consumers, enablers and barriers, policy landscape, role of value chain. And similarly, design strategy was one theme. And this was further segregated into slowing the loop, which is designed for durability. So how to design a product so it becomes more durable, and design for product life extension. Similarly, closing the loop, it also has 2 categories. Then business models, there were different business models these papers have talked about. So most of the papers have talked about product service system models, then resource recovery and innovation model. So that actually answers our research question 2 and 3. So first is to identify what are the major themes. And then the second and third research questions were to further, analyze and identify, say, for example, ecosystem. So how we can place those papers in the ecosystem into different sub-themes. Then was the fourth and the last research question of the systematic literature review process. So which was, what are the gaps that, that are present in the extant literature, so that we could give direction to the future researchers. Now, out of those 94 papers, right, so we identified them into the themes and sub-themes, and then we, studied them for what are the gaps in those researches that can be fulfilled by the future research processes. So every, theme and sub-theme has approximately 5 to 6 gaps, and these gaps will further lead to the research questions. So there could be around 12 to 15 research questions. I've just taken a snapshot of first the gaps, research gaps in research questions that we had proposed for the first few, which is ecosystem. And what we did is, for our further research, we identified gap 2, that we are going to extend this work and now work on this gap number 2. So this gap is like, we have under the ecosystem, we have seen there are many papers which exist on enablers and barriers of CE adoption. But a handful of paper talks about levers, because now the industries and organizations, they have started adopting these circular economy tools and practices. So we wanted to know about these levers, right? So which are the actual tools and practices that organizations can employ or they are employing to effectively facilitate and enhance CE adoption. For this, the research question that we had proposed was, what are the key enablers and levers of CE adoption in EEE sector? So instead of barriers, we worked upon the levers of CE adoption along with the enablers. So then our second research, wherein we have addressed the gap and the research question. So here follows the research methodology. So we adopted a 3-phase research methodology, wherein in the first phase, through literature review, so that's another literature review for this particular paper, we have identified what are the potential enablers and levers of CE transition. And then we employed a Delphi method, and the next stage is gray digital. So I'll go one by one. So that is the first phase. Now, because this is aiming at, studying the enablers and levers of CE adoption. So again, we did a literature review. We refer to a Scopus database. Now the terms are related to circular economy and electrical or electronic industry, with the levers or success factors. These were the keywords that we had used. Then under this process, we could shortlist 29 articles, plus we also have referred to 4 industry reports, and then 2 authors independently conducted a full text review of these articles to extract potential enablers and levers. Then is the next phase. So after getting those potential enablers and levers, we need to finalize that list. So for finalizing the list, we have the panel of industry experts, right? So the Delphi method was employed. So we have had iterative rounds of expert feedback and control discussions to reach a consensus on most relevant enablers and levers. So a total of 17 experts from EEE industry participated. So both for the Delphi method as well as for the gray metal method. And it was a purposive sampling technique that we have chosen to finalize our, experts. So the criteria that we have put upon was, the expert must have experience of working in EEE sector. A minimum of 5 years of industry experience is mandatory. And he or she must have a demonstrable understanding of CE or related sustainability initiative. So the table here provides the description, the respondent's profile, the expert's profile, and you could see, the experts are, a lot of them are senior experts. The first expert is heading the manufacturing operations. We have general manager, deputy general manager, managing director, and vice president. So for all of them, the industry remains the same, which is the EEE sector. They might belong to the different departments like supply chain operations, manufacturing technology, production operations, quality control, but the industry is triple sector. Now, this is basically the final list of enablers that we have finalized after a Delphi method. So enablers, we have got 6 enablers, and levers, we have 7 levers. So in all, we have 11 factors, you may say, which comprises of enablers and levers. So our goal is to leverage circular economy transition in triple E industry with these enablers, right? And what is the benefit out of it? So to have a resilient supply chain and a sustainable future. Now, when we, the next stage is to apply a multi-criteria decision-making approach. So we have applied gray demetal approach. First, why demetal? Because we want to categorize these enablers and levers. First, we would like to rank them, which is the topmost enabler or lever. And second, we wanted to find them which are the cause factors and which are the effect factors, right? Or you may also say we wanted to find out what is the relative influence of these factors within the system. And further, we extended this the demetal technique by applying a gray system theory to it to capture imprecise and vague human judgments. So that results in a comprehensive and unified technique. So then the data analysis and discussion. So first of all, the research question 5. So this I've already discussed that after having a whole round of discussion with the experts, we could gather these 6 enablers and 7 levers. So that is the final list of enablers and levers. And you could see competition is something which we did not get from the literature review, but expert wanted us to add the competition as one of the enabler. Similarly, innovation, we could find it in just one research paper. So otherwise, the other, enablers and levers were there and talked about in the past literature researches. Then the research question 6. Now, there are very few papers which actually talked about whether there exists a relationship between these enablers and levers or not. So many papers, they could find out, the ranking to these enablers or maybe barriers, but levers was not talked about. So that is why we have applied demetal to find out the ranks as well as the interrelationship among them. So we could find out that Industry 5.0, or you may also say the emerging technologies of Industry 5.0, it came out to be the topmost factor, the topmost enabler. So it can be described as the functionality of intelligence systems run by Industry 5.0 technology with a strong focus on human element, helps achieve sustainability in the circular economy. Similarly, circular product design came out to be second in the topmost list. Then third is consumer and society. Circular supply chain is fourth, and government intervention is fifth. Of course, we have got ranking for all the 11. So here I'm just talking about the first 5 factors. And then after that, there was research question 7. So how do the essential enablers and levers influence each other regarding cause and effect relationship? So here, after applying demetal, gray demetal methodology, we got this table as a final result table. If you see Ri plus Cj, so this will give us the ranking to these enablers and levers. The highest value in Ri plus Cj will tell us that this particular enabler or lever is the topmost in the list. So because Industry 5.0 is the highest value, and then we have circular product design, which is 9.481, the second highest value. So that's how we rank them. And then we have another column which is called Ri minus Cj. So they're all the positive values. So they are the cause factors, right? So that means Industry 5.0 technology is a cause factor. If the organization, they leverage these technologies, then definitely they're going to have better circular product design, better circular supply chain, right? So that kind of how these causal factor are affecting the other, enablers or levers. Similarly, if the value is negative, that is an effect factor. So I'll just give you the interpretation of the one of the cause and the effect factor. So which is answered by research question 7. How do the essential enablers and levers influence each other regarding cause and effect relationship? So it is essential to prioritize the cause group factor as they can have a spillover effect on the other factor. For example, our finding revealed that Industry 5.2 technologies may leverage factors such as circular product design, servitized business models, and sustainable and cleaner production. So when these are in place, they'll positively impact the consumer and society. Similarly, we could find out, so there were four, factors which come under the effect factor. So we'll be talking of one over here. So, finding revealed that financial investment is the effect factor for many causal factors. Leveraging circular product design, circular supply chain, and sustainable and cleaner production definitely would lead to a high initial investment, but the results in resources and cost savings in the long run is, low or is better. So that's the interpretation. Similarly, we did it for all the cause and effect group factors. Now, what are the managerial, social, and policy implications of C adoption at a firm level? That has been answered by RQ8. Because every research that we are doing should impact, the industry should have a positive impact on the society, and it should also lead to some kind of policy implications. So, one of the managerial implications that we found out is practitioners must develop a comprehensive strategic plan prioritizing the key factors necessary for transitioning from the traditional linear take make dispose model to a more sustainable and circular paradigm. So basically, this study we have restricted to triple E sector. So probably if we do it for another industry, maybe the healthcare or automotive, so then the hierarchy, the ranking, or maybe the factors would be different. So we need to specify for that industry. So this kind of study would be helpful to the managers to identify what are the important factors for their own industry, for their own organization, and how can they work upon that. Then the social implication, sustainability is incomplete without social equity, that we all know. So circular economy adoption in triple E sector directly influences workers, consumers, and communities extended beyond material and resource flows. Then last is policy implications. So policymakers are the key players, should direct efforts towards governmental intervention, such as enacting laws and legislation, offering financial support, encouraging sustainable practices, and promoting awareness campaigns to foster CE transition. So this will help achieve economic, ecological, and societal benefits, underscoring policymakers' crucial role in this transition. Further, the conclusion, so we applied a systematic literature review to understand the firm level adoption of circular economy. We focused on triple E sector only, and incorporating C practices into business has a remarkable impact on the entire value chain by minimizing waste production, enhancing resource efficiency, and encouraging sustainability focused collaboration among stakeholders. Then the study has few limitations which can open up scope for the future research. So right now we have identified 6 enablers and 7 levers of CE adoption, but they are not going to remain the same forever. So this may not account for dynamic changes over time. Therefore, to capture these evolving enablers and levers and their interdependencies in future, longitudinal studies are necessary. So further studies may emphasize on tracking phases of enablers and levers and how particular enablers and levers gain or lose importance. Finally, the research study is industry specific, focused only on triple E sector. In the upcoming research, scholars can replicate the study for automotive, e-commerce, healthcare. This would help to measure the results generalizability. And these are few of the references. And thank you. So if you have any questions.
Thank you so much, Professor, for your insightful and engaging keynote address. Your valuable perspectives have provided an excellent conclusion to today's distinguished keynote program. We sincerely thank you for your gracious participation and contribution to ICNCDA 2026. And now we arrive at one of the most significant moments of the conference, the ICNCDA 2026 award ceremony. Research is driven by intellectual curiosity, scientific inquiry, and a commitment to advancing knowledge for the benefit of society. Every paper presented during this conference represents months and often years of dedicated research, critical analysis, experimentation, and scholarly effort. The awards being presented today recognize research contributions that have demonstrated exceptional academic merit, originality, technical excellence, and potential impact within their respective fields. While we congratulate the award recipients, we also extend our appreciation to every author whose work has contributed to the success of ICNCDA 2026. Each accepted paper has enriched the scientific discussions held throughout this conference and strengthened the global exchange of knowledge. It is now my privilege to commence the ICNCDA 2026 award ceremony. Beginning with the ceremony, we have with us Sunil Sharma for the award Research, Innovation and Impact Awards, Telecommunications and Connected Vehicles, with the sub-award Research Excellence and Innovation Award. Many congratulations, sir. Next up, we have with us Nagireddy Kerry for the award Software and Enterprise Solutions Awards, Database Engineering and Open Source Technologies, with the sub-award Emerging Technology Solutions Excellence Award. Many congratulations to you. Next up, we have Sandeep Kumar Jangam for the award Artificial Intelligence and Advanced Technology Award, Enterprise Integration and AI Automation, with the sub-award AI in Finance and Innovation Award. Further, we have with us Satish Kanigahali Ramareddy for the award Cloud Data and Digital Platforms Award, Cloud Data Platforms and Financial Systems, with the sub-award Cloud AI and Data Platform Excellence Award. Congratulations, sir. Moving on, we have with us Rajesh Soma for the award Artificial Intelligence and Advanced Technologies Award, Enterprise Automation and Oracle CPQ, with the sub-award AI-Powered Automation Excellence Award. Many congratulations to you. Moving on, we have with us Arun Pratap Singh for the award Artificial Intelligence and Advanced Technologies Awards, AI Agent Architectures and Enterprise Analytics, with the sub-award Applied Artificial Intelligence Excellence Award. Congratulations to you. Moving on, we have Charan Tej Gayapu for the award Artificial Intelligence and Advanced Technologies Awards, AI in Healthcare and Clinical Data Management, with the sub-award AI in Healthcare and Life Sciences Excellence Award. Many congratulations to you. Further, we have Sachin Singh with the award Artificial Intelligence and Advanced Technologies Awards, Wireless Telecommunications and 5G Open RAN, with the sub-award AI Innovation Leadership Award. Congratulations, sir. Next up, we have Nag Madhusudana Rao Chadaram for the award Artificial Intelligence and Advanced Technologies Awards, AI Innovation and Intelligent Automation, with the sub-award AI Innovation Leadership Award. Many congratulations to you, sir. Next up, we have Partha Saradi Reddy Pedamuntala for the award Artificial Intelligence and Advanced Technologies Awards, IT Leadership and Project Management, with the sub-award Applied Artificial Intelligence Excellence Award. Congratulations to you. Moving on, we have Anil Kumar Verma for the award Research, Innovation and Impact Awards, Wireless Networks and Mobile Computing, with the sub-award Research Excellence and Innovation Award. Congratulations, sir. Further, we have with us Rasool Javeed Mohammed for the award Artificial Intelligence and Advanced Technologies Awards, Cloud Architecture and Agentic AI, with the sub-award Generative AI Innovation Award. Next up, we have Hassan Rehan for the award Research, Innovation and Impact Awards, Biomedical AI and Privacy Preserving Health Analysis, with the sub-award Healthcare and Biomedical Research Excellence Award. Next up, we have Praneeth Reddy Badipatiga for the award Artificial Intelligence and Advanced Technologies Awards, Networking, Cloud Infrastructure, and Cybersecurity, with the sub-award Networking, Infrastructure, and Cybersecurity Leadership Award. Next up, we have with us Swapna Putti for the award Artificial Intelligence and Advanced Technologies Awards, Ethic and Applied AI Systems, with the sub-award Applied Artificial Intelligence Excellence Award. Many congratulations to you. Moving on, we have with us Urvish Gajjar for the award Excellence in AI-Driven Quality Engineering and Automation. Moving on, we have with us Ankur R. Tiwari for the award Academia Industry Synergy Awards, AI Content Creation, Management, Architecture, and Enterprise Innovation, with the sub-award Joint Intellectual Property and Product Innovation Award. Many congratulations to all our recipients. As we approach the conclusion of the International Conference on Networks, Computing Systems, and Data Analytics, Icncda 2026, it is my privilege to propose the vote of thanks. On behalf of the organizing committee, I extend our sincere gratitude to the University of Essex, Colchester, England, United Kingdom, for organizing this distinguished international conference and providing an exceptional platform for academic exchange and interdisciplinary collaboration. We express our heartfelt appreciation to all our distinguished keynote speakers for sharing their expertise, knowledge, and research perspectives, thereby enriching the academic experience of every participant here today. Our sincere thanks are extended to the session chairs, technical program committee, reviewers, organizing committee members, volunteers, and technical support teams whose dedication ensured the successful conduct of today's conference. And most importantly, we thank all the authors, researchers, academicians, industry professionals, and delegates from around the world for your valuable participation and scholarly contributions. Your research, discussions, and collaborative spirit have made Icncda 2026 a truly enriching international academic forum today. We sincerely hope that the ideas exchanged, collaborations established, and professional relationships developed during this conference will continue to inspire future research and innovation. Before we finally conclude the conference, may I kindly request all participants to switch on their cameras for a moment so that we can capture the official Icncda 2026 group photograph. We shall wait for a few moments while everybody turn on their cameras. All right, let's give a wide smile for the photograph. Great. Thank you so much, everyone. With this, we formally conclude the International Conference on Networks, Computing Systems, and Data Analytics, Icncda 2026. Thank you so much for your participation, your contributions, and your continued support here. We look forward to welcoming you again at the future editions of our conference. Until then, we wish you continued success in your research, academic pursuits, and professional endeavors. Thank you so much, everyone, and have a pleasant day ahead.